Today we're going to talk about density. Now, density is a property that tells us the amount of stuff in an amount of space. So the stuff that we're talking about is matter, and matter makes up everything. The equation that we're going to use for density is mass over volume. Now, density can have a few different units. What we're going to do is talk about density in terms of grams per milliliter or grams per centimeter cubed. So the mass will have grams, and then the volume will either have milliliters or centimeters cubed. So if the equation is density is equal to mass over volume, we'll divide our grams by our milliliters or our grams by our centimeters cubed to give us our unit of density as grams per milliliter or grams per centimeters cubed. Density is an example of an intensive property, and an intensive property is one that doesn't change based on size. It only depends on the type of matter that it is. So for example, if we have a piece of copper that's this big or a piece of copper that is this big, they will both have the same density as long as they're at the same temperature because they are both copper. So I just said a little something about temperature. So our states of matter do affect our density. So for most substances, solids are more dense because there is more stuff and crammed into an amount of space, so more matter crammed into a smaller amount of space. And then liquids become a little bit less dense because those particles are able to spread out a little bit, still within the same amount of space. And then gases are the least dense because particles can be all over the place. So density is just how much matter and how close it is. But an exception to this is water. When you think about a cup of water, we know that ice floats. And ice is going to be the solid form of water, but it happens to be less dense than the liquid. So for water, liquids are going to be the most dense. The solid form is the middle, and then gas is going to be least dense. All other substances are solid, then liquid, then gas. So temperature is equal to the average kinetic energy. And your average kinetic energy is just how fast particles move. So we said that for most substances, solids, they move the least, so they have the least amount of average kinetic energy, so at the lowest temperature, and they are most dense. And then gases, the particles move the fastest, and so they have the highest average kinetic energy, so those particles are at the highest temperature, and they have the least density. So that tells us that temperature and density go in opposite directions, and that means that they have an inverse relationship. Throughout this course, we are going to talk about different types of relationships, inverse and direct, and so this is going to be the first one you see. Temperature and density have an inverse relationship. So what we're going to deal with most with density, yes, the concept of it, but also being able to solve math problems with it. So if you look on your reference packet, there is a formula sheet. And the very first formula that you have is density is equal to mass over volume. So we do feel like it's an important equation. It is given here for you if you don't remember it. But we're going to use that equation to solve these problems. So whenever you solve a problem, you should pick out the important pieces of information from the problem and then plug those numbers into your math equation. So it says a weather balloon is inflated with a volume of 2,200 liters of helium, and it has a mass of 364 grams. What is the density of helium? So I know that my equation is density is equal to mass over volume. Okay, so it asks for the density, so that is my x. It gives me my mass, which is 364 grams, and it also gives me my volume, which is 2,200 liters. So what we want to do is then take our calculator and do 364 divided by 2,200, and that equals 0.165, and then we know it's grams per liter. Okay, now we have talked about significant figures. So when we look at this number, it has 3 significant figures because those are all non-zero numbers. When we look at this number, we have 2 significant figures because our trailing zeros don't count. So just the 2, 2 are two significant figures. So that means that our final answer needs to be the two significant figures. So the 0 doesn't count. The 1 and the 6 are our significant figures. We look directly to the right, and the 5 will round up to 6. So our final answer should be 0.17 grams per liter. All right, next one. What is the volume in milliliters of a sample of cough syrup that has a mass of 50.0 grams? The density of cough syrup is 0.950 grams per milliliter. Okay, so again, we have our density equation. Density is equal to mass over volume. It asks for the volume, so that's where our X is going to go into. Of a sample of cough syrup that has a mass of 50.0 grams. So that is telling us that it is the mass, so we do 50.0 grams. And it tells us the density of cough syrup is 0.950 grams per milliliter. Okay, so now we have to solve for our X. Whenever you have fractions, the easiest way to solve is through cross multiplication. So you can put your density, 0.950 over 1, and then cross multiply. So you have 0.950 times X is equal to 50 times 1, right? Now we have to get X by itself, so we can divide both sides by 0.950. And we should get 50 divided by 0.95, 52.63, and we're looking for volume, so it's in milliliters. Now we have to go back to our problem and look at our sig figs. Okay, so mass, these trailing zeros will count because there's a decimal place in the number. So this has 3 sig figs. And then our density, which is 0.950. So leading zeros never count. Then the 9 and the 5 always count. And this trailing zero will also count because there's a decimal place in the number. So this also has 3 sig figs. We're doing division here. So 3 sig figs, 3 sig figs. Our answer needs to be to 3 sig figs. So the 5, the 2, and the 6 are our significant figures. The 3 does not round up, so our final answer should be 52.6 milliliters. All right, last one. A plastic ball with a volume of 19.7 centimeters cubed has a mass of 15.8 grams. What is the density of our plastic ball? So let's start there. There are 2 questions, but we can start with this one. So density is equal to mass over volume. So it tells us that the volume is 19.7 centimeters cubed, and it has a mass of 15.8 grams. And it's looking for our density, so that's our X. So in order to solve for X, we have to just divide the top by the bottom. So 15.8 divided by 19.7 comes out to 0.802. Now, here we have 3 sig figs, 3 sig figs, so our answer needs to be 3 sig figs, which it is like this because leading zeros don't count. And so we need to put our units, which is grams per centimeters cubed. So we answered our first question. Then it said, would it sink or float in a container of gasoline? So gasoline has a density of 0.69. So if something is more dense, it's going to sink, and if something is less dense, it's going to float. So because the density of the plastic ball is greater than the density of gasoline, it will sink.